All right, so let me share my screen here. Okay, so I'm gonna dive into the technical questions, not questions, okay, the technical content today, okay? And then we have more extra time at the end. Feel free to ask me questions about other things. We can discuss more about the career and job application stuff, okay? So I relaunched my Eclipse. I can't find it last time. It's actually in one of the folders. So anyway, back to last time, kind of a quick recap. Okay, so we're talking about interfaces. Okay, very important thing in Java. Okay, and as I told you last time, if you show me your Java code, give me any of your Java project. Now, if I start to see, okay, what are the how many files you have in the folder. When I open all the files, I want to count how many interfaces you use. And if I don't see any of the interface, I know you are a college Java developer, okay? But then if I see half of the files had interfaces, defined interface, use interface, I know you are a decent professional Java developer, okay? So this is the thing that it's very easy to understand from concept from the book. You know, it takes maybe half of the lecture to understand how the interface works, but it really takes you a lot of time and experience building project to fully understand the benefits and the meaning of the interface. This thing here is something newly added in Java. Okay, C++ didn't have it, and this is a big deal for Java. Okay, very simple thing, but it means so much more significant than you thought. For example, it's really serves as a kind of a contract for your program. So it's a very important contract between the developers and then the callers. Okay, so the interface is really important. And also interface enables a lot of extensions. When you use interface, because nothing is implemented, so it gives you the opportunities to extend it. All right. Now, last time, if you remember the question we did last time, all right, we're asking you this kind of variable declaration. I told you only constant is allowed in the interface definitions. All right, so that's why if you do int, a, something like this, once you save it, all right, it's going to throw the error. And if you move your mouse over here and then take a look at the error, so it's that the blank final field a may not has been initialized. Okay, so as you can see, very interesting. I did not use a final. If you remember last time, I told you, you don't have to specify final to say it's a constant. If you ever put this one in the interface, it is a constant. So it will assume that there is a final in front of it. So that's why if this is the final, then you have to initialize the value. So you have to give an initial value. All right. But at the same time, I also told you, if you don't put public, it is a public. And then if you don't static, I think it's also a static. So these are the standard way to define a constant in Java interface. Okay, but same time I'm telling you that you can also do things like this: int b equals to 10. That is fine. Okay, so this is just equivalent to this thing here. However, you should never write this one, right? So if you know the standard way to write it, you don't want to be a very efficient coder just to write less. That's not recommended, okay? Because it makes it
Professor?
to understand. Yes.
When you're implementing this, do you need to define A again in your actual class, or is it inherited?
No, there is no inheritance because it's a static, right?
Okay.
So whereas, for example, I have this one here, and then you actually try to implement it. This one had nothing to do with the inheritance, for example, iDemo, right? And then if you want to use that interface, for example, I will do a test method here, right? And you can't really, you can't get the A. You have to do the static way, this way. Does that make sense?
Okay, thank
Yeah,
you.
this is how I reference it because it's static variable. So the interface, there's nothing inside you can directly use and call. All right, that was a good question. Okay, so that was something we did last time. Okay, but again, this one you don't do this very often, and then if you do, and just definitely write in this case, not this kind of concise way. All right. Another thing I didn't write quite perfect is the naming convention here. Does anyone know what's the naming convention when you try to define a constant in Java? So for example, I have a constant here called passing grade 60. So what would be the naming convention you use for this constant in Java? So let me see what you guys say. Camel case, caps underscore. Really good, Ricky. Okay, very good. So yeah, so all of you actually did say that. Yes, uppercase underscores. Okay, so for constant in Java, the most commonly used approach is this one, guys. So instead of writing this, I would put it this way here. Okay, pass grade or passing grade. All right, uppercase and separated by underscores. Okay, but for general class variables, obviously you just want to do the this kind of approach. Okay, the first letter is lowercase and then with all the word. All right, for constant, this is very typical, or in Java. And then you might be asking, okay, can I do something else? Yes, of course. But this is called a convention. Convention means that it's a practice most of Java developers are following. So you should also be following. And don't ask, oh, can I be more, special, unique? You can, but it's useless. Okay, because only make your code harder to understand. All right. So that's some of the things about interface. Last time we also had a question here. Let me put this one here. All right. So we had this question right here asking you that for the interface, what's wrong with it? All right. So a lot of you did mention this. The interface, you cannot have this implementation inside, right? The interface will only define the signature. It's like a contract, but how are you going to implement the contract? That's up to you, up to the classes that decide to implement this interface, right? So that's basically the problem. All right, so that's where we were last time. So let's take a look at one more question, guys. So with this one, then the question is, how can I fix it? All right, so this is the wrong, guys. All right, so, but I'm asking, how could you, which of the following would be correct? All right, 5 options. So I am going to get you the Mentimeter thing again. Okay, so where is, let's still find it, guys. This one here. All right, so try one more time. www.menti.com. I think it's the same code. All right, so I tapped that in the chat. Okay, try if you can join that. And then once you can join it, you can type your answer there so that I know you're ready. All right, so let me reshare it. I'm just gonna share my slides so that you can only see that one. All right. Okay, so here is the question. The question is, which of the following is correct? Oh, code not found. Sorry. 1 second. Just 1 second. Let me make sure this one is working. This is changed. Okay, so let me see. Oh, it does change. Sorry. So 74, 88, 78, and 5 here. Okay, use the latest code, guys. I just sent it again in the chat. Did it work this time?
Yes.
Awesome. All right, so give you 1 minute, multiple choices. All right, give you 30 seconds.
Professor, I have a quick question.
Yes.
During the slides, because one of my friends is already graduate and he wanted to just explain to me about the process we have for solving problems or the coding stuff. As you mentioned, we have a top-down the method we're using.
Right.
And I heard that we have something, the name is down-top method. So we're starting from the basically the answer solution, basically the final answer, and we're going to the top. Is there any way it looks like that? So we're starting from the basically the answer.
Okay. Sorry, to clarify. So you're talking about the software design approach, right?
Yes.
Okay, and then you said that it started with a question.
We always, as you said, we always usually we are starting from top and just we analyzing the problem and making that to the smaller problems and solving those.
Yes.
And I hear about the things that they say we can start from the sometimes based on the problem we have, we can start from basically answer. So if we know what the answer is at the end, we can start from the bottom and go to the top and design the process the inverse.
Yes. So well, basically there is something called a bottom up as well. A very typical example with that one is that happens in a lot of this kind of larger scale type of software. Sometimes, for example, you want to build like a total like a platform kind of framework that want other people to build on top of it. In that case, you basically really have to go bottom up, that you build all these little functions, and then you start to abstract some of the more tasks with them. Some of the great example, I think one would be maybe OpenCV. It's a computer vision library that provide you a bunch of all these functions. Another one, good example that's commonly used, is something called a NumPy. So it's a lot of numerical computing methods provided by Python. And I think for those, obviously you will need that one. But again, I definitely see sometimes you will need to go with that approach. And also like in software engineering class, you were not in the class. We were also talking about this kind of problem idea that you derive your features from the problem and then try to solve it. So, but then keep in mind the top down was the actual old approach. We do not recommend too much today. It was the procedural type of thinking. And today we're more kind of like to go with this real world mapping, real world concept, object oriented, problem driven, this kind of approach.
Oh, okay. Yeah. Perfect. Thank you.
I think what you mentioned, that exists definitely. It definitely works for certain situations.
Oh, okay. Thank you so much.
Yeah, no problem. All right. So let me see the result. I think this time looks like it's better than before. Okay. So, all right. So let me share that with you. See here. All right. So this is your choices. A and C are most selected answers. I think these are the correct answer. Some of you select B, and some of you actually do select D and E. Okay, so let's actually take a look. But A and C are definitely good answers, especially if you already understand the previous one. You will kind of see the point of this question here. All right, so let me come back to the slides here. All right, so let's look at this question one by one. So basically, which one of the following are correct inside the interface? Okay, number one, you got a return type, method name, input parameters, no method body, just end with semicolon. This is the perfect. This is only a signature. All right, and then you don't use a public whatever here, but that's fine. And just like the constant, the variable declaration, interface always assume it is a public, okay? Because this method will be implemented, and this one will serve as an interface. Since it's interface, that basically means that people will need to call and use this one. And if you make it private, it doesn't make any sense, okay? Because people eventually will need to use all of this signature message. So even you don't put a public, interface will still consider that as a public. So A is definitely a correct answer, okay? If you know A is a correct, then B is wrong because you cannot have a protected visibility for this method in interface. It must be a public, okay? I just specifically a specific requirements by the interface because we want to make sure everything you put on the interface are the direct interface people can use and call. So protected will make it less convenient. All right. Now, number 3, answer C is also correct. Okay. The difference between A and C is C, you got is keyword abstract. All right. So we'll talk a little bit more about abstract class, but then if you still remember it, right? So you can create this abstract method in the class. So if you mark this method as abstract, then you do not need or you cannot have the method body, right? So just a very quick review. Here I go back to here, right? So I have this method called public void and then do something, right? This is the empty method in Java. But if I don't have the implementation, okay, I only want to provide a signature. Maybe I want my subclasses to implement it. You can't do this way unless you mark this one as abstract, right? Oh, sorry guys, I did, yeah, this is kind of bothering me. Sorry, thanks for reminding me. Okay, I didn't share my editor, so let me share the whole desktop here. All right, yeah. Okay, so I was just trying to do this one here. Okay, I have a method here called a public void, do something. Right. So this is empty method. This is okay. But if I don't have the implementation, I just want to put the signature here. I want the subclass to do it. So I will need to do an abstract. That way I can put this method here inside the class without having to implement it. All right. However, you can see something still wrong here. All right. And the reason, I don't know if you know, but that's going to be the next question. Is that if your class has one abstract method, then your class become an abstract class. So you need to mark this one as abstract. All right, so that fixes everything. Okay. However, as you can see, the abstract method serves a similar purpose as the interface signature method. So that's why A and C are both correct. Even though you do not need to put an abstract, it is already an abstract in the interface. Okay, but really nobody will write abstract in the interface because that's basically what an interface uses for. Everything inside the interface are abstract. Okay, so both A and C are correct. A is more standardized. Okay, obviously using a public will be better. Okay, so these are easy. Now D and E, well, D has a static code, and then you put code here inside the interface, and then E, you got this default. I don't know if anyone saw this keyword called default, and then sounds like you want to provide default implementation, and then right here you got some code inside. All right, so you guys all know that for interface you cannot have implementation. Okay, so only signature. So by default, you might think D and E are wrong, right? So those were wrong until recently, and there were some changes. Okay, so this something new happened recently. I just want to point it out, but I don't think it's really that significant. I don't see a lot of Java developers use this one, but I really want you to know that before Java 8, okay, all the way from Java 1 to Java 7, okay, Java 7 was around, I think in 2010, okay. When I was using Java, that was Java 4, 1.4, when I was in college, and then I go to Java 1.5. Java 7 is around 2009, 2010, I think that period of time. So, basically in the first 15 years of Java, D and E are not allowed. Right. Now, since Java 8, I think around 2010, then they start to enable these two. All right. So let's talk about these two one by one. First one is the static. So you can actually add a static method here inside the interface. So public static void print info. And then you can do something here. That's allowed. Okay, version 1.0. Right, wait. All right, as you can see, now this one is through the arrow. It says that illegal modifier in interface print, only public objects are permitted. Okay, so this is what's happening before. Okay, you cannot have a method signature like this. But then the reason is I'm actually using a 1.5 Java, you can see right here. Okay, J2SE standard version 1.5. Yeah, I'm using a Maven here. I think it's for some reason they use a really old version of Java. So let me see how I can change it. Okay, so let me try. So this is weird why it gave me a Java 1.5. So Maven change Java version to 1.8. Let me try this one here. Is there a complete more? I need a more complete specification. Just properties. Try this one here. One, and I need another plugins. Okay, so all right, plugins not allowed. Where should I put plugin? All right, so because I created a project with Maven, so this is kind of adding. All right, so let me see one more example. Okay, build is under build. Okay, so let's specify that. All right, so can I update my Maven? All right, okay, guys, I changed the Java to 1.8. Okay, so anyway, so you can play around with different versions. Now I come back to here. All right, so the error is gone. Okay, I can actually use this method. But why this one's through the error? Why this is not? A is not resolved. Oh, because I delete that A. Sorry, that's nothing to do with this one. Yeah. Okay. Okay. All right. So that's something very special. So here is public static method. You can put it in the interface right now. This one only happens after 1.8 in Java. Okay. So this one, it doesn't affect any of the features from interface. Since this one is static, it doesn't matter. It's just related with that interface. Maybe you can use that one as a helper utility method just to run something. You don't have to create an instance. So that one is okay. It's also reasonable. That's why they decided to add it in the interface. Okay. So there's one more thing here. It's more special called a default. Okay. So if you look at slide here, you got a default method. Now, this one is really kind of a newer stuff they added. So basically, you can have a default implementation for your interface. Previously, you can't. But now they start to realize, well, sometimes, not all the subclasses want to rewrite this implementation. Maybe most of them want to reuse the same behavior. If I still want to use the interface, then you can do that one. You have a default. For example, I have something called a print score. Okay. And if default, if you want to try to call this one, is that no student info is found. Okay. If you ever never implement it, if you still want to call it, you don't want to throw an error, just want to give this information, you can have this default print score. Okay, so you can still, let me clear this one, get it back from abstract class. All right. So now, as you can see, if I don't implement this print score, I'm okay, but I can always call it. Okay, so let me give you a test here. So the test d1 dot print score, and that's gonna work. So if I try to run this one here, run it, is that because of the public? It doesn't look very good. Let's see why. Okay, so I think because this is not a public method, so I'm gonna move this one here. Okay, I'll move this one to another class, to this main method. All right. All right. So if I run it here, so I just print out this information. So I'm just using a default implementation for this. Of course, you can still implement it. Or here is the new. So if I do this one, coming back here, I run this one more time. All right, so here is the new score from the new implementation. All right, so anyway, this is really easy to understand. I just gave you a default implementation for your method. But however, you can see if you put this one as a default for your subclasses, if they don't rewrite it, you don't get any errors. Okay, so that's why I want to remind you that use this one cautiously. Okay, because one benefit of interface is that it forces you to write and rewrite something, to define something. But now this is no longer a requirement anymore if you turn this method into a default. It does give you the flexibility and convenience, but it also loses this kind of a contract feature. So that one, but keep in mind that you can do it. But in reality, I really haven't seen too much of usage like this, because this is the big difference from the past Java. So a lot of Java developers, they're not really following this one. But I guess there are some scenario that this feature make the code more easy to understand. Okay, so that is this question here. All right, so this is one, the last two are very special case. I just want you to know it exists, but again, in reality, probably not much use cases. All right, so only after Java 8. Okay, so any questions? All right, so let's take a look at the next one. All right, so this one here, very simple question. All right, is the following interface valid? All right, so let me reset this one. Okay, just type your answer very quickly. Let me reset answer. Before you type it, I can reset it. Okay. All right, now you're good to go. Okay, so whether it's valid or not. All right, so let's take a look at the choices. Okay, most of you think it's valid. All right, so all right, so the ones who choose invalid, what do you think? Why? Okay, so what's wrong with it, and what are the things?
I believe it is valid. You know what? It is valid, but it's useless. It doesn't give you any because we use it interface basically
Yeah.
to help the people who wants to use our program
Right.
so they can use our methods or they can understand what they have to choose for implementing their basically our methods.
Right.
But when it doesn't give you any information, basically,
Yep.
I believe it
Good.
doesn't make sense to having that.
Yeah, good point. Can anyone come up with, okay, let's do this one. So the answer is valid, obviously. So it's okay. Okay, you can do this one without any variable declaration, without any method signature declaration. Okay, but yeah, so the question here, just like Zayat mentioned, what's the point of doing this? Can anyone give me an example of the interface that defined like this? Have you seen any interface like this? Nothing inside, just a name?
I never seen that.
Which one? No? You never seen that before? Anyone type?
I mean,
Uh-huh.
what's the point? I mean, is there any points to having something like that?
Well, I
Such
don't know.
that?
So that's why let's take a look at some examples. Can anyone think about the examples that actually have this like empathy skeleton interface defined like this? Oh, Robert have seen it. What is so was a web app that an annotation above it? Yeah, that's kind of close. Do you remember the name of that annotation or the interface? In fact, in JDK, okay, the standard Java, there are um, a few interfaces like this defined. Okay, not the very good serializable Nick. Okay, so Nick, you want to explain what serializable is? What does it do?
It's how you could turn something into like JSON or other formats, right? Like binary formats.
Right, right. Very good. So how many of you have seen this interface in serializable? It's actually a pretty common one. If you start to write some Java application, uh, I think very commonly you will probably touch this interface. All right. So come back. Let's talk to this one by one. Okay. Come back to the answer. Okay. So the answer is correct. Okay. You can have this kind of a interface definition. All right. And then as I put the slides here, normally we use that as kind of a marker. It's definitely meaningful. Otherwise, Java won't use that one. Okay. The best example is this serializable. Okay. Just kind of give you some ideas here. Let's search for Java serializable. All right. Take a look at the documentation. All right here. And then if you look at the documentation, and I don't think you can find anything here. As you can see, empathy, nothing exists, right? But this one here, basically, if you ever use this interface, normally it means that your class that applies or implement this interface can be serialized. In other words, can be exported into some kind of database format, such as JSON, XML, or some other text format. So let's say you got an object, right? You got a student object, you got a grid name, age, student ID. So you can create an object in Java, set up all the attributes. Now I'm asking you, can you save this object information into somewhere? For example, into a file. Can you write all this name and ID in some kind of format, in JSON, XML, or any other kind of format? So the process of turning an object into a text format is called serialization. Okay. Now, when you use this interface serializable, that means you're telling people that this class, this data can be serialized. Or you provide certain ways for people to serialize it. Okay, so that's why this kind of interface is more serve as a marker. Okay, it indicates your class has certain properties or attributes or can serve for certain purposes. Okay, from the functional point of view, it doesn't give you much concrete things. However, it really helps some of the functions or SDKs people created to make it simpler. Okay, so maybe I'll use this one as an example. All right, so I come back to this one here. Give me a little more concrete example. So I can define a class. All right, I'll call it game. All right, so this one here, we got name, maybe a review, and also a price. All right, and then I can just get some of the getter and setters. All right. Now you got this game object, a game class, and then you can start to create all this game object. I can state that game, and I got game one, and new game. All right, game one does set the name. All right, and then game one does set price, and then game one does set review, maybe 4.5. All right, so you got an object here. All right, so then this is how you operate all the data in Java. Okay, but then when you saving the data in this way, only exists in your memory. Once your program done, then the data is gone. So what if I want to save the content of G1 somewhere into a file, into a database, or whatever? Okay, so that means I need to somehow put those value and data into some kind of destination. Okay, in that case, you can use, for example, there's some Java library to convert object into JSON. There's some Java library to convert Java object into XML. You can define your own thing and write that into a file, right? So there are a lot of libraries that take care of that kind of process. However, this libraries, they cannot deal with any kind of object. You can't just simply send a game object, or later on you send me this iDemo object, you send me this test object. They can't guarantee that whole process works for every single object, because some object like this game that perfect for this case. Some objects, some classes, maybe they're dealing with some kind of functionality. It doesn't make any sense to serialize those. There's nothing you can serialize. They're just a bunch of methods and functions. Okay, so in this case, they will actually say something like this. So let me say, give me an example. I'm writing my I would say, $Sun JSON helper. Okay, so for example, I have my way of doing something like convert object to, right, and then you need to give me an object, right? So I will actually do something here, converting it to JSON. So I will write a lot of code here, okay? And then the purpose of this function is to convert something into a JSON. So for the input parameter, one way I can do is I can say object, basically any kind of given object in Java, right? So I can convert it. All right, but then you see that this is the problem, because the object is the parent class for all the Java classes. If I put object, that means you can throw me any kind of object here. Game object, student object. You can also give me a lot of object that I shouldn't actually convert. For example, the demo, test, system. Those has no much data inside, then it doesn't make sense to convert them. All right. So in this case, what I can do is I can say, okay, I want to only do things that can be serialized. So I forgot how to spell that. Okay. All right. I only want to do the object that can be serialized. All right. So that means you cannot just simply pass me a object type. you must give me a class that being marked with as a serializable. Okay, so in that case, if you want to send your object to this method here, you must make sure that this one here implements serializable. Okay, and you're right, it doesn't give you anything, but you make a marker, you apply a marker, or in other words, it's a tag. You're telling the library that, okay, I am telling you that this class can be serialized. It is safe to be serialized. It is meaningful to be serialized because I have all the data attributes here. It's a perfect class for you to serialize. So now I can send this game object to here. That's going to work for this method. But now if you want to try to send me, for example, some random stuff like the test, okay, it won't work because it's not really serializable and then you cannot use it, right? So these are the purpose of applying these markers. It gave these special tags or attributes to the classes so that it guarantees only certain kind of object works for certain interfaces. In other words, you can consider that as a kind of a special data type. Okay, this type, like I created my program, only works for certain type. And then one way to define that type is to use this kind of interface. All right, so that's why I think the marker is a kind of good way to describe the purpose. All right, but again, this is a mostly used in, serializable, that's one case. Clonable, some of you might have done this one before, that you got a data that you want to clone and make all the copy. Some of the library does help you to clone it, but then again, you need to make sure that this is something that you want to clone and it can be cloned. All right, but again, it really doesn't matter that they can successfully serialize it or clone it. But it's more kind of a tag for developer to follow and use, that the moment that you are implementing this one as a serializable, you should actually check and make sure your things are serializable. Okay, I think that's kind of the purpose. But it doesn't really guarantee, okay, you apply this one, your thing suddenly becomes serializable. It doesn't work that way. Okay, so that's just why this kind of interface exists. All right. And also a really cool thing about the interface markers is that because in Java, I think we're going to review that very quickly, you can implement as many interfaces as you can, right? So I implement iDemo, I implement a serializable, I implement clonable. Okay, I can implement as many interfaces as I want, right? This is the wrong one. This is not clonable. Oh, sorry, I must spell it wrong. All right, you can apply a lot of those. So that means you can actually tag your class with multiple markers. That also makes this kind of class, have more meaning, or it can be served for more purposes. So it's a very flexible way to kind of tag or type your classes. Okay, so you can think about that way. All right. So hopefully that makes some sense. But next time when you see serializable, clonable, all of those, remember this is just a very special interface. All right. So next one, right? Okay, so now I think we're finished. We're done with the interface. So a very related concept in Java is abstract class. All right, so it's very similar. I will show you some examples. But the difference is abstract class, you can have all the regular class stuff, data type declaration, class instance variables, you can have method, you can have implemented method, but you can also have the unimplemented method, which is abstract method. Right. So just like what I showed you, you can have a abstract keyword there and to mark your class as signature. All right, so here's the next question, guys. This is a more kind of a concept question. Okay, let me reset our answers here. Okay, so multiple choice questions, okay? Which of the following belongs to using abstract class? So there are different kind of scenarios. All right, so let me make this one bigger. Okay, 6 different scenarios. Which of the following should use abstract class? All right, so let me see everyone's choices. Okay, good. I'll give you another 30 seconds. All right. So did I share the answers? All right. Sorry about that. Okay, let's take a look your answers. Okay. Okay, so it looks like A, C, D are mostly select answers. I think that looks right. Okay, that looks right. So a lot of concept is serious, but pretty good question to cover the usage of the abstract class. Okay, let's go through this one by one. All right. So number one, you want to share the code among closely related classes, sharing code. Okay, so that means you have some of the common code and some common functionality that you want multiple classes to use. All right, that means you want to write the code. So with that, obviously, you want to use abstract class because abstract class, as I showed you right here, and if you make it as abstract, okay, you can just use that as a regular class by putting all the definition, you can put in all the method, the bodies. That kind of code can be later on shared by using inheritance. Okay, where for interface, and except the ones I just mentioned here, okay, don't take this one as a typical case. In general, you don't use this one interface. Most of the time, interface are only about the message signature, no code there, so you can't really share code. So A is definitely a use case for abstract class. Okay, Now, B is really important. This is something I just mentioned, all right? So like this marker class right here, you can really implement as many interfaces you want. There's no limitation on how many interfaces you can implement from a class, okay? 3 or 5, 3, 5, any number of those. Obviously, you don't have too many, but there's no limitation. So this way you can have some sort of multiple inheritance, okay? But for parent class, which we'll also review, extend, you can only extend one at most. All right. But if you want to do multiple inheritance using multiple markers, interface is the only way to go. So the second one is for interface only. All right. In C++, I think you can do multiple inheritance. In Java, you cannot do the extend with more than one class. Option C, you expect that classes that implements or extend your abstract or interface have many common methods or fields or require access modifier other than public. And obviously, this is a abstract class use case because interface, everything is empty. Everything is public. So if you want to use the private or protected, it has to go to abstract classes. And also, you got a many common method or field. That means we want to share them. We want to use them the same thing. So you want to put a lot of those definition method bodies and having a regular class as a parent class, that is the way to go. All right. So C is also a good use case of abstract class. And then D, you want to do non-static and non-final fields. Looking at that one, you know it's class, right? So everything in interface is all final, is all static, right? This allows you to define a method that can access and modify state of the object. All right, so this is really a use case of abstract class. Abstract class, not the interface. And then the number E, you want to specify the behavior of a particular data type, but not concerned about who implements its behavior, right? So this is why we're using interface, because you specify the behavior, what do you want, but you don't care about who and how they're going to implement it, and what kind of ways to implement it. So that's interface, okay? And then lastly, you expect unrelated classes to implement or extend, all right? I'm not sure if you guys understand this one. Okay, so why it sets unrelated classes? All right, first of all, the answer is this one belongs to the interface. When you do interface, when you implement things, you can often implement unrelated types or interfaces. So the basic example is this one here, guys. So I'm doing something about a game. And then when I implement it, I can implement really anything. Serializable, okay, these are totally two different things. They're not related. You know, this one is about some kind of data and content. This one is some kind of a property. They're not related. Okay, so interface, if you do this one, it makes a lot of sense. All right, but you don't extend, okay? You don't go and extend something totally unrelated. For example, game, if you extend something called like a digital product, that's perfect because they are related. Okay, this one is obviously a subclass of a digital product. But if you want to extend something, for example, what would be the good example? You know, something unrelated. All right. I'll call it streamable. Right. I have some kind of class that does all the streaming stuff, right? That if this one is a class, guys, and then it's not really good to extend it because, well, I take that example back. I think that one might work. It makes sense. So what will be a better example? Okay. You know what? I might want to use an example of a movie, right? So a game, for example, extend the movie, right? This one doesn't make sense because game and the game, movie and movie, they're in two totally different categories. And the game shouldn't be a subclass of a movie. However, I might have a motivation to do this one because a movie has some of the method I want to reuse. For example, a movie has something called stream the movie. So if I use that method, I can also stream my game. Okay, because I want to reuse that method, so I extend that class and build that into my hierarchy. So inside the game, I can call something called from a movie that to stream something, some data to somewhere, right? But this is a very bad way to code because you're mixing the two categories together, which they don't belong to each other. And the really downside about doing that one is you can also have access to a lot of other things about the movie, such as buying ticket, choose theater, all of those that has nothing to do with the game. And then, so that's why it's a very bad choice. So this is why that you should never extend an unrelated class, because the moment you extend it, you're getting all the code, everything, okay? But for interface, it's only about behavior. And then because the interface doesn't specify many things, you can always like create a specific interface for the behavioral property you want, such as streamable, serializable, clonable, all of this. Yes, Jimmy. So that's why that's not a good behavior. But sometimes you have this class that has already implemented. Let's say the streaming. Streaming is going to be a very complicated thing to do. It's not going to be one method, a few lines, you finish it. I don't think that's going to work. But you find this library, this class that had this one method that does everything for you, and that time you will have this motivation to reuse. That's why you want to do that. Right. So, but of course, that means that you should refactor your code to really somehow to split that functionality from that class, so that other class can easily, reuse that without all this extra problems. Okay. So that's one thing. Keep in mind. Inheritance is it's very convenient because it gave you a very good way to reuse the code. But at the same time, you also want to control what you're inheriting. Okay, so the last one is normally for interfaces. All right, so I think we are doing very good. So A, C, and D, I think these are the good answers. All right, any questions? All right, so a little bit one more, inheritance. So we already talked about this one. This one happened in the class. You can extend it, right? And then you got a subclass, you got a parent class, all right? So here's the next question. So this is a very basic question. This one should be something you already learned in 140 or 1400. Okay, so let me reset the answer. Okay, take a look at this question right here. A lot of choices. Which of the following are correct? So A to I. Okay, so there you have three interfaces ABC. You have three classes ABC. So which ones are correct?
Professor, your mic's muted.
Oh, I apologize, guys. Sorry, I was muted. Sorry, let's go through this one by one. All right, so the first one. Okay, the first choice here, class TC1 implements interface A and B. Okay, implements multiple interfaces that's supported and allowed. So this is the most select answer from you guys. This is the correct answer. And that's the benefits of using interface. You can do multiple interfaces at the same time for one class. And then second one, this class extends a one interface, and you can only extend one thing but not an interface. Okay, if you try to use interface, you use implement, not extend. And then the third one, you extend two classes B and C. All right, that is not allowed. All right, so this is different from C++ and Java. In C++, I think you can do multiple inheritance like this, but in Java, you cannot do multiple parent class by using extend. Only one each time. Okay, so the C is not right. The next one, you extend one class B. At the same time, you also implement two interfaces. Okay, so that's totally fine. All right, so this is fully supported by Java. You've got one parent class and implement as many interfaces you want. All right, so the D is also correct. Now the next one here, you have again two parent classes. That's not okay. So this one is wrong. And then this one here is you got two interfaces and then one class, but then you write this order. This one okay, F. Let me take a look at what you guys think. F, okay, half of you actually, less than half. All right, so just, this is very tricky. Like you never roll this way and then never do it, but I don't think this is gonna work. I think Java does is very picky about this one here. Let's try it. So if I remember it correctly, so you can do extend, for example, let's see which one. All right, app. Okay, it doesn't really make sense, but it is a class. So you write this way is okay, but if I put the extend to the end, that's not okay. All right, the order matters. So this one is wrong. Okay, so this ones are about in interface inheritance. Okay, so not sure if you guys ever done that. So interface, I'm going to implement two more interfaces. Okay, and let me see G and H, how you guys are selecting. G and H, so most of you actually choose G, not H, right? So even though in the class we use keyword implement to use the interfaces, but if you want to inherit other interfaces, you actually have to use extend. So the correct answer is H, not G. Okay, this is something I think you should learn from the very basic Java fundamentals. Okay, interface can inherit another interface by reusing and getting all these method declarations, but you need to use this thing called extend, not implement. Okay, this is just the upper set of between to the class. All right, and then lastly, because it's interface, you extend and implement. That doesn't make sense because interface you can only extend some other interface. You can't really do this at the same time. Okay, so eventually, I think the correct answer are A. I think it's D, as well as H. All right. So that is this question right here. Okay, so those are the correct answer. This should be easy. All right. We got some time. Okay, let's actually take a look at one more. Okay, last one, guys. I gave you 2 or 3 minutes to finish the last one. Okay, so this one is about override. Okay, it's a concept that I haven't really reviewed, but you should already know it. I have a parent class and you got a child class. You want to override and rewrite some of the method. So which of the following are okay? Like just looking at the declaration, the signature of the method. give you half more minutes. All right, so it looks like B, D, and E are the most select answers. All right, so let's take a look. So not many people choose A. Obviously, this one doesn't make much sense. Previously, in the parent class, I have a regular public method, then you make it as static. That totally changed the whole meaning of the method, because once you mark it as static, it doesn't even need a class. So you can't override the method by doing this one. In general, when you override a method, you need to keep the signature exactly the same, right? So whatever says in the parent, then you should keep doing the same thing. Now you're adding a static, that changes the behavior of the method dramatically. Even though it doesn't affect people to call it, but that totally changed the meaning. All right, so the A is definitely not a good override. B is exactly the same one, so B is the perfect way to override it. So this is good. Most of you actually choose B, that keep the same visibility, same return type, same method name, and same kind of input parameters. Now the C, you turn from a static to a non-static. That also doesn't make much sense. If that's a static method, there is not really, you can't really change it to the non-static, because when people were calling the static, they may call it a static way, and you change it to the non-static, it's basically doesn't make any sense. It's not really override. All right, C, I don't think many people are choosing C. A lot of you choose D because D follow the same approach as the second one by having exactly the same signature, right? Definitely this is allowed in Java, but from the concept wise, this is no, you are actually changing and adding a different static method, but it has nothing to do with override. Okay, you're just creating another static method. This is not override. So for example, I'll give you this case here. Okay, so I got one class here. Let me actually find one. Okay, so there is a game. For example, I got a public, static void print game, print info, right? So I'm just going to game some kind of game info. And then now I got another class. I got a Xbox game, and extends game, right? So I'm going to write this one again, right? So this is Xbox game info. Obviously, when you are trying to call this one from this class, you're going to get this one, and otherwise you do that one. But this one has nothing to do with override, right? Because the way you call it, you must specify whether it's a game print info or Xbox game.print info. That's the only way you're calling them, and it comes from the different static method. So this is not called override. I think there's a name for this one here. Let me find it. It's called it's called a hide, I think. It's basically yeah, it's just a different kind of a definition for this kind of situation. All right, so but in general, when we are talking about override, it doesn't involve the static. Okay, so that's something to keep in mind. Now, the most important case I want to review, guys, is the last two. Okay, let me see your choices here. E and F. Most of you choose E, and then a few people choose F. I think the correct answer should be F. Okay, now the difference between E and F is E, you are trying to change from public to protected, and then the other one is you're trying to change from protected to public. Okay, one of them is correct. Okay, even though I said that most of the time when you override, you have to keep exactly the same thing, but there is one exception that you could modify the accessor. or visibility. And then the question is, which way is allowed? Can you change from public to protected, or can you change from protect to public? Okay, I think the correct answer should be F. All right. Now, you never need to memorize this one, okay? But then you really need to think about the whole object-oriented concept, all right? So if you have something previously being used or accessed by everybody in the parent class, when you are doing your special subclass, you have to maintain the same visibility, right? So for example, let's say we have a car, okay, a car as a parent class, which has a method like a brake, speed up, drive, or stop, park, all of this method, right? So let's say the brake method. Brake method should be like a public method that every kind of a car should have. Now you're implementing some kind of SUV car, and somehow you make the brake to be protected. That means only your subclass can access it, not everyone can call it. That's going to be in trouble. Because if you believe SUV is a type of car, and when you implement and extend this class, use the car as your parent class, you must maintain all the behaviors from the parent class. You cannot reduce everything defined in the parent class, because that's going to cause a lot of trouble. However, if your parent class, let's say the car, okay, it has, getting electrical charged, and that method maybe is limited, only apply to certain cars, not all the cars, so they make it as something like a protected. But now you build your electrical car, Tesla car, right? And then you can make it as a public. Basically, if you're using the electrical or Tesla car, then anyone can call this method to do the electrical charge. So if you remember the things in this way, you don't have to memorize, oh, can I enlarge the visibility, or can I reduce the visibility? All right, so the answer is you can extend the visibility, but not to reduce it. So that's why the last one is okay. You can change from protect to public, but not the other way. All right, so hopefully that one makes sense, guys. All right, so I finished almost all of those, but there are a couple of tricky questions. I'm going to leave it at the end. Okay, sorry, next time. So we'll finish this one next time. But definitely, if you feel kind of weak on some of this interface, parent class, inheritance, abstract class, definitely go back, take a look at some of the chapters, and then have a good understanding about it. So we will use a lot of these structures very frequently. All right. So let me know if any questions. Otherwise, I will see you next time.
Thank you, Professor. Have a good one.
All right.